Hello everyone, in this video I am going to discuss second lecture of the calculus 1. So the lecture is basically based on the types of the function. So first type is that polynomial function. So a function p is called a polynomial if px equal to 8 n x to the power n a n minus 1 x to the power n minus 1 so on in a naught. So we can say that function is px is like that, px equal to 3x cube plus 5x square plus 2x plus 1. So this is in a polynomial function where an minus 1, an minus 2, these are real numbers. Okay, so next function is that power function. So a function of the form fx equal to x to the power a, where a is any constant. So we can say examples: fx equal to x to the power 1 by 2, x to the power 1 by 3, x to the power root 2, root 5. So any constant, a is any constant. So these are the examples of the power of the function. So okay, so next function is that rational function. So a rational function f is a ratio of two polynomials fx equal to px divided by qx, where px and qx are polynomials and qx does not equal to 0 for any x. Okay, like fx equal to 2x square plus 5x plus 7 divided by 3x square plus 5x plus 4, but provided 3x plus 5x plus 4 does not equal to 0. Next type is that algebraic function. So a function f is called an algebraic function if it can be constructed using algebraic operations. These operations are addition, maybe subtraction, multiplication, divisions. So like we can write fx equal to root x square plus 1. We can write this in an algebraic function. Okay, now coming next type of the function on trigonometric function. So we know basically that trigonometric function: sin x, cos x, tan x, sec x, cosec x. So these are cot x, these are the trigonometric functions. Next type is exponential function fx equal to e to the power x, a to the power x, where a is positive. If our a will become e to the power x, so then we can say that natural exponential function, natural logarithm, natural e is an e basically e is an irrational number, so exponential number. So exponential function. Next is logarithmic function. Logarithmic function is an inverse function of exponential function. So fx equal to log ax, where a and x both are positive. Now coming the definition of piecewise function. A function f is defined by fx equal to f1x when our domain is a to b, and in this domain b to c function is defined f2x. Maybe more than we can do more partition: c2x, d, f3x, maybe more than 2, more than 3, more than 4. So this is a piecewise function. Now coming on the definition of even or odd function. So if a function f satisfies this condition, f of minus x equal to f of x for every number x in its domain, so then f is called even function, and for odd function satisfy this condition. Now we can see some example. Let us suppose that fx equal to x square. So we replace x by minus x, so it will come x square, and that equal to fx. So we can say f of minus equal to f of x, so it is an even function. Now we are taking another example of odd function. So here f of minus x equal to minus x to the power cube equal to minus x cube, so that equal to minus f of x. so it is an odd function. Okay, so there are many examples of the even and or odd function. Next type is increasing and decreasing functions. So a function f is called increasing on an interval I if satisfy this condition: f of x1 less than f of x2 whenever x1 less than x2. And it is called decreasing function on I if satisfy this condition: f of x1 greater than f of x2 whenever x1 less than x2 in I. So we are taking here in one example. This is in a graph of an examples which is defined on 0 to 2 and 2 to 4. So 0 to 4 this function is an increasing, and 2 to 4 this function is a decreasing. So function is increasing when x belongs to 0 to 2, and function is decreasing when x belongs to 2 to 4. Increasing then satisfy this condition: f of x1 less than f of x2, and function is decreasing f of x1 and greater than equal to f of x2. So now we should stop here. So in the next video we will discuss the limit of the functions. So okay, thank you.